Okay, let's continue. Good afternoon for all of you, and also for the wide audience in the internet globally. Nice to have you on board as well. My name is Jari Reini, and I come from National Land Survey of Finland. My day work is related to standardization, so what kind of interfaces and how to model data content. So I'm working in standardization. In OGC, Open Geospatial Consortium, and as well in ISO TC 211, which is technical committee number 211 related to geospatial information. And I'm also a member of our national SDI group, Spatial Data Infrastructure, where we develop this kind of functionalities, what you will see and hear in the next 90 minutes, more or less. The agenda for today is first a couple of slides about content, what kind of content is available. We opened our data 1st of May, then some mentioning about Helsinki Region InfoShare, Statistics Finland, etc. Then I also have few screenshots about quantum GIS, how to combine CSV files and then put those together with shapefiles. And then maybe 10 to 15 different sample codes, how you can start to work with geospatial information. I will use a tool called OpenLayers or JavaScript library, and then different server-side implementations like Web Map Tile Service, which is in the first one, something related to JSON, also Google Maps, how to start working on that. Also OpenStreetMap, how to locate your current location using API and so on and so forth. And last but not least, also a little bit about spatial analysis, how to do that on database level, not using these desktop GIS tools, but from programming perspective. And then I also promote our own open source map window called Oskari, open source karttaikkuna in Finnish, and that's more or less everything to cover today. Do not hesitate to ask me at any point in time, so if you have a question, raise your hand or shout or something. If I'm too eager to explain something, I may not see always your hands, but try to do your best. Okay, this was a big news. 1st of May we opened quite a huge amount of our content to have topographic maps, background maps, aerial imageries or orthophotos, database, vector raster, laser scanning content. So now you can download those freely from our website, which I will show you shortly. It includes, of course, some terms of use, but it's in principle, if we are not reading all these bullets, you can use it in the way as you want, but you have to mention, of course, terms of use. That's a normal procedure. We have a web service from which you can download content. We will look at that, make a few selections from there. Also, our manual data orders have grown 30% after 1st of May. And then Pekka and some others have blocked their interest also in paikkatieto.com, which is Pekka's blog. There is in English and Finnish a short introduction about how to take this wonderful NLS content and to use that. Then there is a website called latuviitta.org, also maintained by one individual person, which really gives you a lot of information and background how to actually handle geospatial content. And then the last link, kartat.kapsi.fi, there are also files available for your immediate download. And also it includes some web services, so you can actually use those web service interfaces directly in your code if need be. There is a bit boring list of content, so it's more or less the same as in previous slide where I had some screenshots about content, but in different formats and different scales we have content available. This is in our website as well, this information. One of the interesting things is that we are using a coordinate system called ETRSTM35 FIN. So it's not in GPS coordinates. And these kind of data handling we are talking about today as well. So how can you use our content in our national coordinate system, and how you can put your GPS coordinates or your current location on top of our coordinate system. For instance, in my GPS watch, I'm getting location all the time, but it's in latitude, longitude. I can upload it into the Google Maps, which works perfectly. But if I have my tracks from here and I would like to put it into my own map service using this content, I have to make some modification or conversion to different coordinate systems. This is the download service website, which works from the left-hand side. You can select what kind of product you are interested in. Usually those are delivered in different tiles. So we will have then, when you select something from the left-hand side, then you have tiles here and you select from which region you will order content. And then on the right-hand side, you will have a shop basket or something like that. And then you place your order. It will send you email when the content is available, and then you click on the download link and you will get the content on your local machine. But most of this content, if not all, are also already provided by different BitTorrents and also this kartat.kapsi.fi. So if you are not so keen on manual work on selecting content, you can also download the full content from different websites, and this Pekka's blog explain these different sites from which you can download the content. Today I'm also revealing or publishing a little bit more content. So we prepared new data sets from what you can see on the slide. So some state administrative agencies, regions, municipalities, language distribution, etc., etc. So we combined NLS Finland content and aggregated there also Statistic Finland information. And this will be in GitHub, or I'm not sure what will be the final location for that, but I have one zip file where all this is available. Those will be delivered as shapefiles and will be in our national Finnish or national coordinate system. When you will download your content, be careful with the data size. In here I'm selecting from capital region only 4 tiles of auto images, and you can see the file size on the right hand side. So it's 140 megabytes, 150, and if you select the whole Finland, you have 3 or 4 gigabytes. So it's not always that convenient to use those, so be careful, have your server available where you have enough quota and also enough disk space to put your content. Another option is to use directly some web services. So for instance, National Land Survey, we have web services available. You can test those. Not all of them are for free, but you have an opportunity to have a username and password for limited time period where you can actually use those for Apps for Finland competition. And also more content you can download from NBA, HRI, Finnish Environmental Administration. There is a service for downloading content from environmental information, Statistics Finland, Finland.fi or Suomi.fi. They have JSON representation APIs where you can select content. And then if you have username and password for Haka authentication for universities and research. Like I'm an employee also at Aalto University, so I have a username and password for this Paituli service, which is hosted by CSC. And there are many others as well, but I think these are a good starting point for you if you would like to implement some applications. So our content, OpenStreetMap, then some national content from Finland. So you have great opportunity to implement your nice innovations, and looking forward to see your nice applications as well. But this is a starting point. Now we have content. We can use it via Quantum GIS, but we need some implementation on top of that as well. Next we'll look a little bit into content handling to prepare content for web services, and then I will show some JavaScript examples. So, content handling. Pekka had a really nice presentation and even much more nicer online demonstration how to use Quantum GIS, and as he mentioned as well, there are OpenJump, UDIC and other tools if you are not so keen on this application, but I think it's quite powerful. What I've done here, I also have these municipalities. It's easy example to start with, and I have municipality code, name in Finnish and Swedish, and then I'm actually putting content from a CSV file. So if you have some CSV from some statistical information, you can join that CSV file directly into your shapefile. So I have only 3 attributes here. Municipality code and name in 2 different languages. But if I have a CSV file, I can use in Quantum GIS function for joining content, and in that case I first open this CSV file, which is presented there below. It's one municipality key figures CSV. And when I've opened it, I can then look into what kind of fields you have there, different names and other information available. And then I may join this content by using, in this particular case, I'm using municipality code. So in my CSV file, I have municipality code, and I have municipality code in my shapefile. So there is a key between those, and I'm joining those. Kuntakoodi equals to kuntakoodi, and finally I have a new table where I have not only these 3 attribute fields, but I have all the rest from CSV file, and here I have clicked on one particular feature and seeing all the information. So if you have any content which you have a key, for example municipality code, you can combine those in this Quantum GIS. It can be done of course on database level, but it's much more nice looker if I'm putting it in here. Then, as Pekka mentioned as well, Shape is de facto standard for GIS formats. It's developed by Esri. Pekka knows that quite well as well. And in our workshop, I'm using a GDAL OGR library, which is also open source toolkit for converting features from one type to another. So for instance, if I have content from my watch, which is in GPS coordinate system, there is those longitude and latitudes. But I would like to show those in TM35 Fin, so national coordinate system. I can use this OGR library for converting information. I can't demonstrate that online right now because my own computer, which is not also Mac, we were not able to use this desktop presentator. So I haven't installed it here. It might be there, but we should not waste our time to looking for too much software. But I have two screenshots how it works. So the tool is called OGR to OGR. It's command line tool, and you have different parameters there to type in. You can also clip some content using some bounding boxes, lower left corner, upper right corner, so you can select your content from different region. You can change your coordinate systems. You can change the format. And if we are looking into example, in this case I'm changing, I have a shapefile called capital region, so having municipality boundaries from capital region, and then I'm changing those from shapefile to JSON, and this is the function to do. So the file output format will be JSON, and then what is the input file is capital region shape, and then it will be in the same coordinate system as it was originally. If I would like to convert also this shapefile to other coordinate system, in this case I'm converting it to nice code EBSG 4326, which means WGS84, so the same coordinate system as in GPS. So all these different coordinate systems, 2,000 or 3,000 coordinates, are more or less supported here, and you can make those conversions by using this tool. And what is the output? It will create a new file. So there's no wow effect on that. It just makes a conversion and store it as a new file name. Like in this case, it will be capital region WGS84.json. And then finally, you will put those content to different web services and different implementations. And now we will start looking into that level. So now we know the basics of GIS. It was in 15 minutes. We know how to use GitHub, so you can store your application and code there. We know how to combine different content, how to make different coordinate systems and conversions. But now, next, finally, we are going and digging into the details how to implement some applications. First, we must start with some boring standardization stuff. It will help you. So we use so-called web map service as an interface to get map images from the server and then show those on your application. So one is web map service, and another one is so-called web map tiling service, where you have stored predefined images in the server side. So the difference between these is that you can take this web map service content directly from your database and put the visualization there, or these are more cached images on the server and much faster to retrieve, because you actually just pick up some images there, and these open layers and other tools know how to use this interface, so you don't need to take care of what's happening behind the scenes. And then also, if you are interested in vector content, there is interface called Web Feature Service, which will allow you request content and you will get it back as KML or GML, which is Geographic Markup Language, or as JSON or other formats as well. So if you need some local or in your application vector content, you may in that case use Web Feature Service. But be careful. There's no need for you to take the whole Finland data as vector content into your browser, because it may be 200 or 300 megabytes. So even though you have nice Macs, your Safaris won't survive about that. So think in your application that you only select content from the area of interest. You may have a background map from NLS Finland, having some basic maps there as a background. But if you are doing some online analyzing on your client, just select the region where you are interested in. Don't take the whole Finland content into your application if you are working in capital region. So some logic there behind. So Utsjoki may or may not be in your interest. If it is and you zoom in there, then you select content from there. And more standards you can read from OpenGeospatial.org website. All these standards are freely available. So just go to opengeospatial.org/standards, and then on the left-hand side you have a list of different standards. You click on one particular instance, and then you can download it and you can read and make use of those. And there are also some best practices papers which may be more interesting for you. So how to use these standards in practice, not just boring standards text. These are also available as ISO standards, but then you have to pay for that. So it's up to you. You can select free content from here, or you can go to iso.org and you can buy it. Up to you. Same content inside anyway. So this is the big picture, what we are covering in our implementation. This kind of 3 or 4 tier architecture. You have on top your JavaScript or any other Ruby on Rails, whatever library you are using. And these are more virtual things, this service bus, but it must be there because it's nice to have service bus. It doesn't mean ESB, so it's not enterprise service bus, but kind of common service layer, rights management, to have usernames, passwords, authentication, authorization, stuff like that. But right now we are not particularly interested in these two, but we are looking more into the service layer. I mentioned about this discovery, so this paikkatieto-ikkuna or geoportal.fi. You have this discovery service, so you can look for content from there. All the metadata is there. All the information about your content is there in standardized way. So you can even ask it from your direct application and make queries and ask information. Then we are using interface called CSW Catalog Service for Web.
A question: how well standardized is the international architecture? Are the discovery services, for example, similar in all European countries, or do they use the same vocabulary?
Very good question, and indeed that's the case. So this is actually architecture by Inspire, which is European Commission implementation for European spatial data infrastructure. And all these services are the same in Sweden, in the Netherlands, in Portugal, in Spain, in the UK. So all these functionalities, all these things are available in all European countries. So if you have your nice application and it's working here, and if you're using these service interfaces, you can sell it globally or European-wide. Interesting. But in our case, so we use this web map service to have map content from the server side to our application, and then we will use this, it's called download service, but it's in practice it's this web feature service where you will actually get the vector content back. And National Land Survey, we have a couple of implementations. Finnish Environment Agency, they have similar implementation, and all of these government bodies are implementing in the same architecture this implementation. We are not covering registry service, including Morse code lists and stuff like that. Also transformation service for coordinate transformations is available, but it's not very efficient. It's more about one coordinate there and one back, not really huge amount of content. And this WPS is web processing service, in which you can make some functionalities there that you send some content into the web processing service. It will make some modifications, for instance using behind the scenes OGR to OGR, and then it sends back you the content. So you can make some nice map visualizations there, you can make some generalization and stuff like that in this service. So how to make this web map service and web feature service and other stuff available? One open source tool is called GeoServer. It's running within Java servlet container like Tomcat or Jetty or JBoss or Oracle Application Server, you name it. And in easiest way, it's just you deploy GeoServer WAR file there, and then you have application available. The next step is you log in, then you will publish some content. So you have your server side, for instance, these shape files, what we've been looking, municipalities, etc. And then you publish it, and then you have web map service and web feature service available. So the procedure more or less is in this slide. So in 1 minute how to use GeoServer, add store. So select if you have a database, Oracle, well no Oracle, we are in open source community, PostGIS, MySQL, different databases, or if you have raster files or shape files, add a store, so make a connection to your content, then create a base map, selecting few publish functionalities, then you have an opportunity to make different styling for your content, like Pekka demonstrated these maakunta areas and different colors. You can define it by using so-called SLD, styled layer descriptor, which is also one standard 150 pages to do different kind of visualization options on server side. And then finally, when you have WMS, Web Map Service, WFS, Web Feature Service up and running, then you use and test it, for instance, by using open layers. And then when you are implementing the application, you have to look into so-called get capabilities, which we are looking briefly in some of the next slides. But if you're not interested in setting up your own GeoServer or any web map service, you can also use service hosted by National Land Survey. So here is a URL for our service. There is a test page also available, which actually explains how you will get content from the service. I will sit here and show a little bit. So, for instance, what you will put into the request when you are asking some information. First, you are interested some layer. So I'm interested in basic map raster images. I would like to have it back as PNG format. The size is 500 pixels. I have national coordinate system, etc. And when I send this kind of get key value pairs request to the server side, it will give me back image like what I have here. We can also look it online, so you will understand how it works. So here is the URL. Copy it. Have a Firefox. Paste it. It will require authentication, which I will not let you know, but you can request it from National Land Survey. I don't want to remember that. So here is the test page for that. So the same screenshot what I have, and the interesting thing is that when I click on this send request, it should be available also in English, but maybe our international participants are well aware of WMS, so we will have it in Finnish. Well, let's have it in English, so we have a perfect delivery of this content. Okay, so here is the get map request. So I'm asking for a particular area, which is this bounding box. So coordinates from lower left corner upper right corner, so it will ask from the server, give me map back, and when I send this request here, send request button, look the URL on top, it will have key value pairs. So service name is webmap service, it has a version number, it's asking map, so it's get map, and there is a user ID which is meaningless in this case, width 500 to 500, format is PNG, so this is as PNG file. Layers is our basic map, style is normal, I can have it in different styles so it will have a different look and feel. So this is basic key value pair coding against the server side. But when you are using these open layers, leaflet, other JavaScript or other libraries, there's no need for you to know how it works, but this is what's happening behind there in the JavaScript. So they are doing this same request to the server side, and then in your application you just browse your map. So for instance, in this example, you can see that there will be new tiles coming all the time when I'm browsing, so it will sending in parallel maybe 100 different requests to this webmap service and giving responses back. But in this case, this open layers is doing that, so there's no need for you, but as a developer you're always interested in what's happening behind there. So the actual thing is that this service is sending that kind of requests what are there in URL. Let's go back to the presentation. Yeah. So this is the web map service also in few minutes. I'm teaching this at Aalto University in my geospatial programming a bit more, but please come there if you are more interested in how web map service functions. I put here demo add content to GeoServer, but maybe at this time we may look into that later on, but it's really easy process, and we might have some time schedule problems, so I leave and skip that at this point. So the basic library we are using in the implementation is OpenLayers, available at www.openlayers.org. There are also some books available if you need some help for beginners guide. Some kind of open layers for dummies is also available. You are not dummy, so you can use this kind of book. And here is an example of open layers. So very simple, only having zoom in and zoom out button there on the top left corner, and then you can drag your mouse and change the map view. This works also in iPad, so it has touchscreen support. So if you will implement the application in using OpenLayers, you can run it also in iPhone or iPad. JavaScript in that case can be also OpenLayers Lite, where you have less code to download for your application. But in any case, touch screen is also supported. Here is one example, and in this I'm reading content from our own WMTS web map tile service. If I open the code page, it's this one. No, it's not that. This one here. So first I will select some different codes what I'm using. In this case I'm using online, so directly from openlayers.org. And here is the main OpenLayers JavaScript, what you need in your application. You can have it locally or you can have it dynamically from openlayers.org. of course then you have some potential break there that if it won't be up and running, it must be locally as well. This whole left-hand side package will be delivered in GitHub, so you can use these examples as it is. I have a reminder there in the last slide also about this, so don't put those in really practical use. There are no exception handling and whatsoever things, so these are just examples. And I have these libraries also here. I have Open Layers library locally, so it will be covered and be included in the package. And then we are using one conversion library called Pro4JS, projection for JavaScript, which will make these coordinate transformations. For instance, in this code, I'm first creating a map, which will be Open Layers map. Its units will be in metric system, so I'm not using latitude, longitude, not any degree information, but it's metric information. Then I have some resolutions how the different layers will look into my application. And also, as we are using now national coordinate system, I'm also including here the support for this national system. So this is one of the most important things when you are starting the development from our National Land Survey services, that you always have in your application support for EPSG 3067. That's the code number for our national coordinate system. You can look and browse from the web. There is EPSG, a registry where all the coordinate systems are covered. Don't worry about these. These are some parameters, and I'm not even expert on these because I haven't studied geoinformatics or cartography. My background is in computer science. But these are things what Pekka knows, these zones and projections and stuff like that. Yeah.
So how is the Open Layers map connected to the document object, the tree? So how does it become visible on the?
Sure. So you can.
Did I miss it already, or?
No, it's well. I haven't mentioned it's in DOM. It's there as one class, and then you have all the information there, and also all the requests, all the individual map tiles are also in the DOM model. We may look into that also shortly. And then here I'm reading information, so I have so-called capabilities. I have it locally here, which explains what kind of layers I have available in my server, and then I'm just setting center to my map. So in this case, it's metric system. It's from Finland. These coordinates look like this, and then there are different zoom levels. So am I looking into small scale or big scale on a map? And if we are looking this in a browser, I have only on load in body. So it will ask this initialize or init function, and then it puts in a divider map into that. And in my application, it's actually this implementation. So in the code, I have also here index. So there is index.html. So this is a starting point for you, and then you will see this kind of page where all the links are for the examples. And the first one, and what I presented as source code, is this one. So it makes this divider map there, and then it connects to our service. And then I don't care right now how it works behind there. Open Layers takes care of that. We have more examples, more fancy functionalities in next slides. So here's the screenshot. Of course, this presentation will be available in GitHub as well, or SlideShare, I don't know, somewhere. They will take care of that, so please contact them in case you would really come back to this presentation later on. Okay, so I presented already this Open Layers and this webmap tile service stuff. Then you are also always interested in JSON stuff. So JSON is one format which supports points and lines and polygons, multi-points, etc. Different types. URL for the website is geojson.org. More information about GeoJSON. And here is one example from GeoJSON. So it's a multi-polygon. What is this? It's Espoo. Geometry for Espoo. It's in Swedish Espoo and in Finnish Espoo. Municipality code is 049, and then I have a big list of coordinates, which is in so-called well-known text format. So the first and last coordinate for the polygon must be the same, so it means that those are closing and then it's polygon. But let's not go into detailed coordinates, but this is an example of GeoJSON. Here I have a application implemented again using OpenLayers. Now I'm not using web map tile service, but I'm using a GeoServer. The reason why I hide this server name is that it's one of my Amazon cloud services and it's really open at the moment. I'm not willing to share it. But in practice, we are now using localhost in our example. So in my, well, this is not my computer, but in this Mac, we have a GeoServer up and running. So it will ask localhost port 8080 GeoServer/WMS. So that's the contact point from which it will ask information. And then I'm asking one layer called Suomi 4.5 million, and there is a bit of metadata in the name so that I know that it's in our national coordinate system. And then I'm centering the map to this coordinate listed here, and then I added a few controls, few tools into my OpenLayers application, so it will show my position in real world, so in which coordinate my mouse is moving. And then I also add GeoJSON available. I have it locally, as you can see from URL. It's in folder called data, and there is capital region.json. So I made it with this OGR to OGR GeoJSON file, and then I use it from local server to this application. Before you will ask, we are not supporting JSON padding or JSON-P. So if you need some different servers, so the JavaScript policies that you are not allowed to go to different, what is your origin, so you need either JSON-P or you may implement your own proxy. But just implement your proxy and use it in that way. It might be that at some point in time GeoServer will support JSON-P, but it's community-based. It requires some funding for that, so if someone is paying for that, it will be there. But at least at this point, no one has have implemented that. So we have WMS, Web Map Service, from localhost, from GeoServer. I'm asking this kind of map layer, 4.5 million background map. Then I'm recentering my map to somewhere here in Helsinki region. I'm adding some tools, and then I'm adding GeoJSON stuff from my local computer. And if I go and look into that example, I have it here. First it comes with this JSON stuff, it's faster, and then later on this this background map. So this is coming from my local GeoServer at the point. So this is one example, I mean, in the sense that if you need some vector content in your application, use it in this way. Don't take the whole Finland. It's this in JSON format, this municipality borders, it's about 2 megabytes. So it doesn't make sense to have it in your application. Then you may have some local functionalities like info tool or pop-up window. When you click on this, it will give you a pop-up window and explain information that this is Nurmijärvi and its municipality code is something. So all the content what you have available in your JSON file. So in our case, if I would have an info tool, it would have this kuntakoodi, nimi FI, nimi SE, and that's all. So that's all the information I have available in this example. And the source code is available here. So available as one HTML file, and again included in the package to be delivered to you later on. Done. Google Maps. I will not go into the details of this. It's so well documented in this developers google.com website, so you have all the information there. There are a huge amount of samples. I've made an application for showing Google Maps, again using initialize function, having some map options to have some center position. In this case, it's done by using GPS coordinates. So this is latitude, longitude, not anymore our local coordinate system. And then I'm just showing a map. I made this example when I was living in Brussels, so that's why it's from there. So it's quite old example, but it's also delivered here as Gmap. One important thing from Google Maps is that you need always a key. So you have to make for your specific server your IP address. So you must register your IP address where you will host your application, and then you will get a key for that. And here is a key for localhost. In this case, so it works because I'm running it within a local host. Please do not use this key. Well, you can use it in localhost, but it's under my name. I don't know if it makes any problems. Maybe not. Again, what else? I will show it. So going back to my home page. Map with Google Maps. I also put here the same source code what is there, and then I have my map here functioning. I can switch to satellite image and stuff like that. I'm not sure about the current limitation of Google Maps. It's maybe some 2,000 requests per day when it's free, but if you have more requests you have to pay for that. So it's not completely free anymore. Also be careful when you are adding some overlays or own content on top of Google Maps. It may be used by Google as well. So I would be a bit careful with this one. It's easy to start with, it's easy to use, but you won't get innovation prize by using this basic Google Map service if we are looking at it from that viewpoint. I'm supporting Google, no problem at all. It's wonderful, but just a few reminders. Okay, how much time I have time? I have time. Okay, next. Done. So I presented it already. I don't have this as a source code available, but just many of you are LAMP based developers, so you have Linux and you have MySQL and PHP and stuff like that. So here's one example I made a couple of years ago to get KML, so keyhole markup language, the Google format, what you can put on top of Google Maps or Google Earth. On the left hand side I have two clips from source code, so one time only to create a table, KML POI, points of interest table, having some fields there, latitude, longitude, maybe the most interesting, so to have coordinates there, and then some description and auto increment to have new unique IDs, etc. So this PHP will create the database, the table into your SQL database. And the next one is inserting content there. So if you have your web application, you can create and insert content. I tracked some GPS locations back in 2008 or 9, and I used this script. Of course, there is a bit more as well, but just to have an idea how to implement that. And then I have how to get this KML, how to request, make a connection to the database. So to my MySQL server, well, error in that case if it doesn't work. And then I'm selecting, this is maybe the most interesting part, to select ID, name, latitude, longitude, description from the table. And as we have then finally the result set available on the bottom, MySQL query and SQL. And then I'm after that creating output, so I have here a string building and looping all the rows, and I'm creating new KML5 file. And so this is the syntax for KML, starting with namespace and icon. I have, in this case, I have a static icon, so I took it just from Maps Google website. And then I'm using looping here all the rows. And then finally I'm ending this XML as document KML, and then depending on my header style, if the content type will be Google Earth or KML, then it will automatically, when I retrieve it, look for my computer and open it in Google Earth in that case. Or here is for demonstration purposes, header set is text XML, so I can look it in my own web browser, for instance. So these kind of functionalities you can create if you have MySQL database. MySQL also supports some spatial functionalities, so if you enable spatial functionalities, you can make some queries there. I will now show later on, not using PostGIS, not using MySQL, but I'm using so-called Spatialite, which is a file-based, really small, tiny geospatial database. I will show some examples later on. But you have plenty of different options for database to have spatial functionalities. Commercial side, Oracle and Microsoft SQL Server, it must be. And a question from there.
Maybe I missed it, but what coordinate systems and projections are these JavaScript libraries using?
All these JavaScript supports many different coordinate systems. So this Pro4JS projection for JavaScript, it supports all the coordinate systems. So you have to put those available in your code, and then you can use those. KML itself, when I'm creating this kind of stuff, it's using GPS or WGS84 coordinates. So it's directly coming from your GPS device.
Why sometimes the order of coordinates is latitude, longitude, and sometimes longitude, latitude?
Good question, and it's really a painful thing. Yeah, it's also standardized in that way. So if I have this EPSG 3067, which is our national coordinate, I have one order, and if there is an other, is it 4258? I don't remember by heart, but those are in many different orders. And also if you are using in two different orders in that case, sure. And also if you are using this web map service, if you are using version 1.1.1, it's always the same order, but if you are using 1.3.0, it might be different. So it's, do you know what is the background or reason for that? But you have to kind of invent it, you have to test it, and then you realize it. We had a, I can't say it because it's online.
Yeah. But in PostGIS it's different than in web services usually, and people get mixed up when you are in the web interface, you do otherwise than in database. Yeah, it's tricky, but yeah.
It is. And very good question. You may have been working with some coordinates earlier. Okay, then also of course you can have, when you have this KML available, here is my so-called service.fi, where I have this code. The URL or server name is not correct one. It is available, but I didn't want to reveal that. So you can show your POIs or your KML information also on top of Google Maps when you just present parameter q equals where you have your KML available. So if I'm going maps.google.com and then q equals, so one key value per parameter, it will retrieve my KML using this previous page PHP code. It will generate this KML file, and then it will put it on top of this map, and here I have sample 1, sample 2 and sample 3. That's the information I have at the moment in that database. Or you can have it also available in your Google Earth. So if you have Google Earth and you click on this sample PHP, it will automatically open, or it will ask, may I open Google Earth? And then it will show, here I have sample 1 and 2 and 3 also, and I clicked one of the examples here, and it popped up me info window. So this is basically some of the Google things. But again, if you will create this KML stuff and you have some not so open information, this may or may not be used by Google as well. So please read license agreements, as you always read all the license agreements. Read carefully from Google when you start implementing, especially some professional or I mean business applications that content might be also used by Google. Then in my architecture, or in the first slides, I had a web map service, and I mentioned this web feature service where you can get this, for instance, JSON back and information as vector format. One good example of using WFS, so this web feature service, is to use NLS address search functionalities. So here are URLs for information from what is available there, but I will show it as an example how you will actually communicate between our web feature service from your client and getting responses back. Now it's slightly more complicated. It's not anymore key value pairs in your web browser, but you have to send post requests to the server, and then you will get a response back as XML. Here is a request, so I'm connecting to ws.nls.fi. I will send this XML document using post there, and what I'm asking, I'm going to query type name osoitenimi, address name is the feature type or the layer name, and I'm making a filter, so I'm querying their information. I'm interested in knowing in Helsinki, Opastinsilta 12, and it will give me back coordinates. So all the coordinate address information is available in this osoitenimi layer or feature type. And then I will get response back where I have a little bit overhead. I'm interested only in coordinates. So the red circle there, I'm interested in that, but it will give me a little bit more back. So this is so-called GML, Geographic Markup Language. So I sent a request, and I'm now getting back this XML, and here is my coordinates, and now I can use some parser to take these coordinates and then recenter my map to this particular location. So this is how to use this web feature service for address search. So in your new application, most likely you have some functionalities that you would like to search for addresses, you could use this one. So first send request via HTTP post, and then get back GML and looking into location and point, and if you have multiple addresses or multiple information, if you only put Opastinsilta but not number there at all, it will list you all the addresses which are from Opastinsilta, so 1, 2, 3, 5, 7, 12, etc., etc.
Could you query for several addresses with one request?
I think yes. So as you have here this OGC filter, so this is one request, and then you have AND functionalities, so you may have second AND, third AND, fourth, fifth. So yes, I'm pretty sure it works in that case. And now if I look into my this poster here, I made already some preparation work here. So I have from Firefox Chrome poster tool.
Sorry, is this some kind of plugin?
This is a plugin for Firefox called Poster. Very nice. I really like it.
Why does the Windows say Chrome?
Don't ask me that. I don't know. Nevertheless, first you have URL where you are sending your request. It's in our case we are using secure HTTPS. Authentication is required, so please contact web services NLS.fi. You will get a username and password there. I think it's not really electronic procedure. You have to actually sign a paper and send it back. But I'm working in government, so it's different. Okay, URL. Here is my request. So this is the request I'm asking. In this case, also it's this Opastinsilta, and now I'm posting information there, and it will give me. It's not very nice styled way of presenting, but there we have these coordinates somewhere here for this location. And then in JavaScript or in your implementation, you parse this information and use it later on. In the same way, you can use also when we talked about this metadata. So we have this catalog service. You can send a request to catalog service, and if you are interested in some kind of content, you can make a query, and it will give you information back that what kind of content is available in Finland for these services. But I didn't cover this catalog service in my slides this time. Okay, so done. So HTTP post using this poster, and WFS web feature service as a service interface for looking your address. The next is more about other WFS web feature service examples, and if I just briefly look into this, I have this my local host GeoServer here. I can close this one. So in web map service and web feature service, there is so-called get capabilities, which explains what is included in our service. So this says that Claudius Ptolemaeus is responsible of this server. It's a default name for GeoServer installation. But what we are interested in, if we are looking using these services, we are interested in what kind of output formats you have available. So in this case, it will give you back GML, geography markup language. It can give you shape files as a chip file. So in chip you have shape, a couple of different files. It can give you back comma separated files. it can give you back JSON. So these are kind of metadata about this service, what it supports. Then it also explicitly explains what content is available. So I have here NLS municipalities is my layer I put there. There is by default some tiger data from South Africa and things like that. And then also, very interesting and important point is that it supports also different spatial operators. So if you are sending a request there, some coordinate or some geometry, you can ask if it's in Helsinki or if it's in other place. So some spatial analysis can be done by using this service. So you send a request, you use some of these functions, and it will give you result back. And also more functions. So actually quite a big amount of different functions are available. So you have option to implement your functionality either at your JavaScript level, so you will code and ask some information locally in your JavaScript. You can send a request to server side and you can make some analysis there, or then you can make these same functions on database level. I will show you database shortly. Other information here, I'm asking content from the service. So if we are looking this third bullet or third example, I'm asking get feature is the service or the request I'm doing. I'm asking get feature with municipalities, so municipalities layer. I made an additional parameter max features equals to 1, so it will only give me one municipality. So that's a filter for that. I could, if I leave this out, it will give me 345. So all the municipalities. So it's more convenient if I will only pick up one. And here is one. I don't know the order. Is it going from database first line or what is the logic there? But here is this GML, Geographic Markup Language. It's in our national coordinate system. Here is the geometry. It's a linear ring, a polygon, and it seems to be Utsjoki what it gave me back. If I'm interested, the same thing in other format. So the same as in previous, but if you look for the URL, I had additional parameter called output format equals JSON, and now it gave me JSON back. It's not wrapping the line, so it's only in one line, but it seems to be Utsjoki again. So you can ask in different ways. You can have output format as KML, so then it will give you Google's keyhole markup language, etc. But these are just examples for your later usage. If you would like to have your municipality information in other coordinate systems, you just have a SRS name equals URN blah blah blah, so it will give it in different coordinate systems. So if I'm asking this, the final example, I'm again asking only this one municipality. So here is the original request. It's in our national coordinate system, but if you would like to have it in WGS 84 latitude longitudes, now it voila gave it back, and now I have the same information but in different coordinate system. So if you are putting it in top of Google Maps, for instance, you may use now this kind of information. So the important thing for you is that always do match coordinate systems. So if this coordinate system would put on our national coordinate map, it would be in wrong location because we have different numbers there. put it in that way. Okay. The next topic is geolocation. We are using W3.org API for getting the current location. So depending on your browser or your tool you are using in iPhone or iPad, and your browser may or may support it. Here is an example to convert from GPS coordinates to local coordinator to Google coordinate system. And in this example we are using this projection for JavaScript tool to convert coordinates. So what I've done, here is coordinate conversion. I show it from here. So again, I've included different coordinate systems here with these EPSG codes. This is Google's projection. If you are looking at this number 900913, it looks like Google. So that's the logic why the number is slightly different from any others. So it's easy to remember that how you would actually spell Google in numbers. So it's 900913. We don't have similar for Finland, so there is no. Okay. Am I getting tired? I'm trying to make some jokes. Okay, so here examples. Geolocation. The first one, it always asked if you haven't give a yes earlier, that are you willing to share your location? And now it used this API, and now it tells me what is my current location for this device. I'm in this longitude and latitude, and accuracy is this 30 meters or decrease? It can't be decrease. I don't know, I have to look into specification, but you have conveniently a link there, so you can look into what it actually means. So some homework for you as well.
I think it's in meters.
It can't be in decrease at least. And then I have a different from GPS, the same application but a bit enhanced. So I now have the same coordinate in also Google's or web Mercator projection, and also in our national coordinate system. So this you can use as a template if you need to switch between different coordinate systems, and here is also a link to this projection for JavaScript library as well, which is, by the way, included in library folder in the package. And from source code point of view, the function is like in here, transform source destination, and the final parameter is the point itself, and then it makes a conversion, and I made an inner HTML print into the website to see it. You will understand it pretty well, I suppose. Okay, next one, OpenStreetMap. OpenStreetMap is interesting in the sense that it's easy to use in open layers. It includes already directly open layers a class called OSM. So here I made again a map. So we need a map, and then we are adding layers, and there is already a class called OSM, OpenStreetMap. So when I include that, it will use directly OpenStreetMap web service. No need whatsoever to put any other information there. Then in this case I also asked for current location. So in this I have navigator geolocation function position. It will ask the current location, and then it will make a transformation from GPS coordinators directly to web Mercator, or the same projection what this OSM is looking. So now I didn't explicitly put there a projection code, but I wanted to convert it to the same projection what this map has. So asking from the map what is your coordinate system, and OSM is in Web Mercator. Then I made a marker, so this pixel size marker, I put an icon which is from Apps for Finland website, and then I'm adding a marker on top of the map. And then I'm setting center to that location which I'm getting from this function. So next example will be like this. Yes, share location, and now it will show me OpenStreetMap and the current location where we are, and I put Apps for Finland logo as a marker on top of that map. So you may implement in your own source code different icons and different ways of putting markers. Now of course I should enhance this example by having again pop-up window, and it would say that this is Forum Virium's location, and etc. etc. This pop-up functionality is well defined in OpenLayer's online sample. So just go there and look for info tool or pop-up window. Just copy paste the code and it will work smoothly. I take a technical break for a bit of coffee. So, next thing we are interested in, or you may be interested in, is to have some analysis. So, for instance, who are my neighbors from this location, or in which country I am? If it's clear for you that you know in which country you are, but the application itself, it doesn't know. So then you may use some spatial SQL or this web service interface like I showed in this get capabilities. So it will give you true or false information about your request. You can process things, you can make some measurements, what is the distance from this location to other location. And from technical viewpoint, you have option to use it as database or map server like GeoServer or in different libraries.
Could you use that for filtering out small islands?
Sure. I might do it faster than you on database level.
Yeah. Okay, start to implement your database now, and I'm already done with your chit-chat.
But this would be reusable, so it would have a source code and you could use it later on. No need to make a manual desktop work again and again and again. Okay, good point. I'm pretty sure you already managed to do that. It would take me for 2 days to figure it out. Points, lines, polygons, so different content what we have. And these are just examples of some of the functionalities you may ask from either from server side or from JavaScript. So if A contains B, or if A covers B, or if these are touching or intersecting or overlapping or etc. etc. You can read, of course, those from the screen as well. And what I'm doing shortly, I will make some examples. But here is a list from standardized functions you may use. So, for instance, in this data you showed where you had some topological misunderstandings, or it didn't go that well. So you could use some of these functions to make it automatically as topologically correct. What we are usually interested in application development is touch. Area is interesting. If it's not in attribute information, you can always ask area from the spatial object itself. Buffer is very widely used. So you ask something from this location and then you make some buffer, what's happening in 50 kilometers or 10 kilometers or something like that. Distance is direct from point A to B, so it doesn't include any route calculation, then you should use different tools. PG routing is one of the tools. It's running on PostGIS, additional package which would support really car navigation and really route calculation. So overlaps is one to be used, and these are things I'm involved in the standardization. So these are basically these same functions work in different implementations. So if you have PostGIS or if you have MySQL or you have commercial tools, they in any case implement the same standard functions, which make code more reusable for different organizations if they have different databases as they usually have. So examples. In which municipality I am. So I'm using spatial SQL, select name FI, so name in Finnish, from municipalities where my location, so here I have my coordinates, I'm creating a geometric point from that, and then I'm matching it against this municipality geometry. I have it here as an example as well. So I'm using a Spatialite tool. Now it's slightly bigger. So first I start Spatialite, then I will load some content there, and then I make some queries. So select name from municipalities where my point, so wrong request. So this point for this coordinate matches to my municipality's border, and it will give me that this coordinate is in Helsinki. Then I might be interested in knowing from this location, so I now have this point, I'm creating a buffer on top of that, so 50 kilometers buffer, so here is 50 kilometers buffer around my current location, and I'm asking which municipalities are intersecting that polygon. So in practice I have my point here, I made a polygon, and then I have my municipalities here. Nice map from Finland, and it should be even here. So this kind of request, and then it will return me what municipalities I have there. And this SQL will then give me that in 50 kilometers there is Hausjärvi, Helsinki, Hyvinkää, etc., etc., etc. One question might be, this one. I have some issues with characters. So what are the neighbors of Helsinki? So I'm selecting Helsinki boundary from database and asking which municipalities are touching Helsinki border. And now asking it will give me Espoo, Vantaa and Sipoo. So these kind of functions you may use either at database level or then in your JavaScript or in web feature service.
Is there any support for a time dimension? For example, the municipal borders are changing a lot, so does this include a time dimension aspect?
Not really in that way. Of course, if you have your layers in different time dimensions, but I think they are not really time. Yeah.
Yeah, they are. You can have a time stamp for the features.
Okay.
So you can store the time when it's...
This time Oracle supports and some others, but
But
the
then-
Spatialite is not supported, but it's file based. But
Yeah, you can do that. Easy answer maybe. But yeah.
But generally, do the file formats have that kind of time-based information?
not really in files, but database is
Yeah,
So it's
yeah.
more like
for-
metadata then
That's a fourth
and
dimension.
yeah.
It's a fourth dimension. You can have fourth dimension data in PostGIS for it's more possible.
File format you should have just several files. But
Yeah.
in database you can have the time dimension.
Yeah, it's
Okay. Then we are moving to the end shortly. Have a look at live.osgeo.org. There are a lot of tools available there. There is even OSGeo Live virtual image, which runs on Ubuntu. So including a huge amount of different tools. So just take it and use your virtual box or whatever virtual machine you are using, and then you have these tools what we presented today and much more. For instance, Open Layers, GeoMyJazz, which is actually based on Google's App Engine, MapBender, MapFish, you name it, a lot of different browser clients, more like portals in the sense of a lot of functionalities. PostGIS is there, Spatialite is available, Rasterman is for raster stuff, and then PG routing for route calculations. Yes.
Was it easy to install this Spatialite on Mac?
You can install. I have it on Mac.
Okay.
I just used it.
No issues.
Yeah. So this is on Mac and it's there. Yeah.
It appears also there's an Android version of Spatialite.
Yeah. Might. Yeah.
I don't know how well that works.
Yeah. It's really simple one. It's really file based, and it requires a little bit of course source code or binaries there, but you may have a shapefile in your, like I loaded a shapefile. It's my database, and it's very convenient. And I'm using usually for demonstration purposes instead of installing all the PostGIS stuff and putting services up and running. Now it's easier to show it here, and including the same functionality. So different databases are in this OSGeo Live, desktop GIS, Quantum GIS and other stuff. UDIC is based on Eclipse framework, so it looks the same look and feel as Eclipse. Then different spatial tools for manipulating your content, ETL tools like GeoKettle, Mapnik for really nice looking beautiful maps, how to render those in nice way. R, open source statistical stuff, you can use that as well, and much more. And this is only from this OSGeo. There are other tools which are out of this organization, but I would recommend of downloading this. It's something 4 gigabytes of it runs on memory stick. Nice. Well, it's not that fast directly from memory stick, but I have it in my memory stick as well. Then we have our own from National Land Survey. We have Oskari, which includes different libraries like Open Layers, but we made some enhancements on top of that. You may have a look at that website, oskari.org. We are already in version number 12, which is on top. There below there is the first version, so this is the evolution. A lot of functionalities deployed and put as an open source, so you may take all the source code there and have this kind of implementation immediately available. So have a look at that. I didn't have time to make an example of this, but also on Oskari website you have examples we are using so-called bundles, so how to make additional functionalities for this framework.
What sort of control system are you using for that Oscar?
We have now SVN, but we are moving to Git. Or actually it's now on Git.
Okay.
So all the source codes will be available. I'm not sure, are we forking or how, you know already how to use GitHub, but I have my own here as well. I will put those there and then we can use it in the way as you already showed us nicely. But use those at your own risk. I haven't done any testing and there are no exception handling and anything like that, so I don't want to be accused about my wrong interpretation of how to implement stuff, but use as examples. I hope this will help you at least a little bit.
Jari, can you elaborate what might be interesting or useful in Oscar? How much is it dependent on the environment where you build Kartta-icon, and how much is useful outside of that?
It's currently it's running inside a Liferay portal, so it's having kind of dependency on that, but we have been moving more independent way, so you can run it as it is. So it's a bit more complex what I've explained here earlier, but if you are really doing some more productive system and you need more functionalities, drawing on a map, putting your own places, storing on the database and stuff like that, then it might be a good, and it's used a lot in governmental institutes in next few months, so it will be one of the frameworks to be used in Finland. So I would suggest to look into that, but maybe not for this competition. I'm not sure if it's too GIS related. So, and then if you are interested in more, next Monday in Stockholm, I'm hosting together with OGC Nordic Interoperability Day. Interesting topics from Euro geonames, gazetteer service, so searching place names, interoperable systems by Saab, about civil security, how to project things, authentication, authorization. I will have a presentation and stuff like that. So it's already on next Monday, but it's easy to go to Sweden. So looking forward to see some of you there, at least one. And I think that was more or less all for today. Now you may have any questions, so you can also later on send me email. I'm working at National Land Survey, not a startup company anymore. We just got 200 years history. Had a nice party a week ago in Finland to celebrate 200 years by National Land Survey. Thank you. Questions?
And please browse through the Etherpad and read through the questions that other people have asked. Maybe that helps you in coming up with questions that you would want to have answered.